Good evening. So, welcome to the NPTEL course in the live interactive session Transition Metal Organometallic Chemistry Principle to Application. So, in this session, we are mainly solving some sample problems which is related to the assignment problems, and by solving the problem we will understand this week content, that is week 4 content, in more detail, and I will point it out the more important topic and more important point which to be remembered in this week lectures. So starting from the last week, that is week 3, we have started discussing this course a very interesting chapter or topic, that is the CH activation process. The CH activation is very important to convert the naturally occurring hydrocarbons, mainly alkanes, to the value added product. Now because of the high energy of activation of CH bond and the selectivity of the CH bond to active is very difficult, because is high energy of CH bond as well as the control of functionalization of CH bond to give value added product. So for that we use the transition metal organometallic complexes to perform this reaction in a catalytic fashion to active the CH bond, as well as the stoichiometric reaction to convert these hydrocarbons, that means alkanes to value added product. For example, we have seen that we have activated the hydrogen of methane CH bond, and we have converted that CH bond hydrogen replaced by hydroxyl, that is OH, to give methanol, which is a very good value added product to the hydrocarbon. So like that way we can convert many other alkanes or hydrocarbons to different value added product. So in this week we have mainly discussed the process of CH activation, mechanism of CH activation, examples of CH activation, how to characterize the CH activated product, and lastly the importance of CH activation. So I will wait for another 1 or 2 minutes if anybody else joins. After that I will start discussing this week content through this problem solving session, where I will discuss today, as per yesterday's class request, I added 8 more questions, that is total 18 questions I will discuss in today's session for understanding or this week content. But I did not instructed to go out of this course, or that is not allowed. So I will restrict myself to this course content only, as well as the week content for each session. So I will wait for another 2-3 minutes if anybody else joins. Otherwise, I will start discussing. Whoever joined, if you have any question regarding the yesterday's session or the previous session, you can directly ask me. Without writing, you can also tell in the turning on your microphone. This session is mainly to clear the doubts for the students who has joined the course and to show how the problems or MCQ has been solved in the proper way in different competitive exam as well as the exam for this course. And if you have any doubt regarding the lecture videos taught by the professor, just post your doubt with the lecture number and time in the discussion forum. In discussion forum, we will try to give the best answer as quickly as possible. So if you have any doubt regarding this week or any other week regarding assignment, regarding question pattern, anything, you can put your doubt to the discussion forum. You can ask, and our team if you have any doubt, you can always welcome to ask your doubt in the discussion forum of this course. We will try to answer those doubts with the discussion of the professor as early as possible. So I encourage you, for better understanding this course content, please ask your doubts in the discussion forum and get your doubt cleared directly from the professor in that forum replay. So without wasting any time, I will start discussing the questions for this week content. If you know the answer, you can tell me. If you don't know, that's also fine. Just see how they are solved. And if you have any question for or any doubt regarding that question, you directly ask me in between this session. Okay, I think my screen is visible. So welcome again for the problem solving session or live interactive session for the NPTEL course Transition Metal Organometallic Chemistry Principles to Application. So our first question is the reaction of dihydrogen with. So today, as per yesterday's session request, I have added 8 more questions, that is total 18 questions I will discuss throughout this session. If you know the answer, just tell me the answer by turning on your mic. Don't use the chat box because in this screen sharing mode I cannot see that chat box. Just turn on your mic, unmute your mic, and you can tell me the answer. So I will discuss 18 questions in today's session. So
option D, sir.
Yes, the reaction of the dihydrogen with Wilkinson catalyst to form a 6-coordinate complex is the beta elimination, reductive elimination, ligand isomerization and oxidative addition. So what is the formula of Wilkinson catalyst? What is the chemical formula of Wilkinson catalyst? I have already discussed this catalyst in previous classes. So Wilkinson catalyst is RHCl PPH3 whole thrice. So this is the chemical composition of Wilkinson catalyst. So here the oxidation state of rhodium in the catalyst is 1. So first, and the coordination number is 4. So during the addition of hydrogen, it will act 2 hydrogen H to give the rhodium 3 complex, and hydrogen will act as a hydride, so which will contribute, this is Cl and 3 ppH3 will be like this. So this will be coordination number 6. So coordination number 4 to 6 is the oxidative addition reaction with the increase of oxidation number from 1 to 2. So the addition of dihydrogen in the Wilkinson catalyst to form a 6 coordinated complex is the oxidative addition. Next question is, the oxidation state of the metal atom in the following complex is?
+3, sir.
Yes. So oxidation state is +3. Last step, I show how to calculate the oxidation state for any metal complex. So here you can see that the iridium complex is as a whole neutral, so there is no outer charge here. So to calculate the oxidation state of the central metal, I will first let it X. Then here we have hydride and chloride. So therefore that we can write -1 and -1. Also we have an aromatic ring attached to this iridium center, which will also contribute a negative charge. As overall charge is 0, so that corresponds to 0. So here X equals to, we can write +3. This is the way to, here that ppH3 is there, but that acts as a neutral ligand. So we have neutral ligand phosphorus and the 3 ionic moiety attached to this iridium. So the oxidation state is +3 in this complex. The next question is, the acoustic interaction is, here we have 4 figures A, B, C and D. The which figure represents the acoustic interaction between the metal and the hydrogen? Which figure represents the acoustic interaction?
Option B, sir.
Okay. Then if it is option B, then why not option A? Because you can see that option A and B is slightly different. Here one hydrogen moiety is interacting with metal. Here the two is interacting. So if C and D are different, then if why not A?
In agostic interactions,
Yes, an agnostic interaction.
less than the bond length is less than 2.3 angstroms, I think so. But in this, it cannot display any bond length and bond angle.
Okay. So in agnostic interaction, you are right. That answer is not right. Your option number answer, but in agnostic interaction, we should have bond that hydrogen should be closer to the metal. That is right. Here you can see in the last we have discussed the beta hydride elimination. So beta hydride elimination, we have metal attached to CH2, CH2, CH3. So this interaction between the metal and hydride gives the beta hydride elimination. So this is a kind of agnostic interaction, or this is the agnostic interaction. So for agnostic interaction, this carbon molecule should be bound to the metal center, not a like one carbon. It can be like this, maybe CH2, 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 or CH2H. So now this chain arranged such a way that in molecule that this hydrogen and this hydrogen in metal is close to each other. They can perform the agnostic interaction, but here you can see that metal is a entity outside from this molecule. This one also same, this one is also same, but here in option D, that one ring or one bond is attached to the metal. So there that interaction is close, or when metal is attached to this alkyl chain, then the agnostic interaction is possible. This is for these types of interaction we have discussed in the last lecture, or the second last lecture, that is lecture number 19. This is called the metal sigma alkane. This is alkane. These three types of interaction, not sigma alkyl. This one is sigma alkyl complex. So these three are representative example of A, B and C sigma alkane interaction in the complex. So the agnostic interaction only occurred in sigma alkyl complex when the carbon atom or carbon is linked to the metal. So here option number D will be right answer. You can refer to the last, I think 17 or 18 lecture, where these three types of hydrogen bonding or three types of interaction in sigma metal sigma alkene complex is explained. So option D will be the correct answer. Then question 4 is the consequence of agnostic interaction in C sigma alkyl complexes is or are. We have just discussed the agnostic interaction. What will be the answer? The consequences of agnostic interaction in sigma alkyl complexes is, that means the agnostic interaction is always occurred in sigma alkyl complex, and sigma alkyl complex is generally represented by R. Mr. R is an alkyl group. So the agostic interaction always present in metal sigma alkyl complexes. Okay.
Option B, sir.
Huh?
Option B.
CH bond strength increases. Option B. Okay. So here I have already discussed the agostic interaction in the last. Here the agostic interaction happen in sigma alkyl complexes. So for the sigma alkyl complexes, let's say we have M CH2 CH2H. So this is a kind of metal to hydrogen is agostic interaction, and for this interaction what will happen, that elimination of alkene,
Beta elimination.
so that will leads to the beta hydride elimination. So that is one answer for this question, but this question has multiple answer. So beta elimination is one of the answer for this question. So another answer is, if we have metal with CHCl2, we will read, this will be discussed later on of this course when we will discuss the carbene chemistry, metal carbene complexes. So generation of carbene will be here to after abstracting this hydride. So that will lead to the Cl2 carbene. This elimination of hydride is called the alpha elimination process. This also happens due to the interaction of hydrogen with the metal center. This is called the reversible alpha elimination process. So this will be another correct answer for this. Another thing, that here it is written CH bond strength increases. So for the agostic interaction, we need to know that this bond is breaking. This CH bond is breaking because of this agostic interaction, and for that we can say that CH bond strength decreases here. Okay, so CH bond strength decreases, reversible alpha elimination process, also the beta hydride elimination is the three consequence of sigma alkyl complexes having the agostic interaction. Is this clear?
Yes, sir. Yes, sir.
Okay. The next question is, the presence of agostic interaction is best described by. The agostic interaction is metal, carbon, hydrogen. So we are considering the interaction of this metal and this hydrogen only. So how to determine that there is any interaction or not? Which method, experimental method, that will determine these types of interaction? This is the question. How you will determine that any agostic interaction is there or not? There should be an experimental evidence or proof which shows to us that the agostic interaction is present.
Magnetic susceptibility.
So here, okay, so think this question in another way, that we need to determine the agostive interaction between metal and hydride. So we don't know which metal and hydride also. The organic moiety is generally diamagnetic. Also, in the transition metal catalyst like rhodium, iridium, whatever we are using here, that are also most of them diamagnetic in nature. So dealing with the diamagnetic substance, magnetic susceptibility never come into the picture. So directly we can cut the magnetic susceptibility option, because magnetic susceptibility word is valid when you know the exact metal and its geometry, and that metal should be paramagnetic. Paramagnetic means the metal should have the unpaired electron. Okay, then only the magnetic susceptibility we will consider. So here we can directly cut magnetic susceptibility, because we don't know which metal, we don't know which ligand. So let's assume our rhodium iridium complexes which give these types of ruthenium agostive interaction, they are all diamagnetic in nature. Okay, another is mass spectroscopy. So the mass spectroscopy gives us the overall mass of the molecule. There is no interaction, they cannot detect any kind of interaction between the, and this interaction is intramolecular. So this interaction also does not affect the mass of the molecule, whether that is interacting with the metal or not. Okay, so mass spectroscopy also not possible. Another is the UV visible spectroscopy. So what determine UV visible spectroscopy? UV visible spectroscopy or absorption spectroscopy generally determine the two things. One is the metal, another is the ligand, they attach to the metal. For the ligand part, if we have a pi conjugated system, in the ligand, it will show the UV visible absorption. Okay, so for also the metal will show the DD transition band for transition metal complexes. This, that is the DD and pi conjugation, is the pi star transition is calculated or observed in the UV visible spectroscopy. But the interaction of the metal with the ligand, a particular atom like hydride, is not possible the UV visible spectroscopy. The only option remains is the neutron diffraction method, and that is the correct answer for this question. So here you can see that one of the approach to get the correct answer, just use your the knowledge which you are already gained from your undergraduate level or into 10-12 standard. Simple knowledge. Magnetic susceptibility not possible, because these complexes are always diamagnetic in nature. Mass spectroscopy gives the overall mass of the molecule. There is no interaction is possible through mass spectroscopy. UV visible only give the electronic transition, not possible. The only option remains is option A. So that will be the correct answer. So by eliminating the options, you can also get the right answer for the question. This is the one of the approach to get the correct answer. Also, sometime you will see that you can by like this way you can eliminate the two wrong answer. Let's say C and D. You can eliminate. So these two are never possible. You may have confusion with A and B. If you tick one, that will get your correct is answer correct is probability 50%. So that is with the 4 option you can go to the 2 option. That is the one of the way to eliminating the options and to get closer to the correct one. Okay. The question number 6 is, in the reductive elimination step, an electron rich late transition metal would. In the reductive elimination step, an electron rich late transition metal would. It is saying that facilitate a nucleophilic attack, favor the elimination reaction, hinder the elimination reaction, and facilitate an electrophilic attack. So the reductive elimination step is after getting the oxidative addition, that is a complex with M with higher oxidation state like +3 with the 6 ligand, it go back to the original catalyst with 1 to give 4 ligand after eliminating the 2. This is the reductive elimination. So here the coordination number decreases from 6 to 4 and the oxidation state also decreases from higher to lower. So this is just opposite of the oxidative addition. So this is the reductive elimination step. So it's saying that the reductive elimination step, an electron rich late transition metal. So our metal center is saying that this metal center is electron rich. That means it already have lots of electron. Okay. And here in reductive elimination step, that is this step, it is going to -3 to +3 to +1 stage. So for +3 to +1 in reductive elimination, that is the reduction. Reduction means again gain of electron, that is the electron gain. Gain of electron, that means already it has electron rich, again you are adding more electron. Obviously that will not possible. Already it in this state it has saying that electron rich, that means already it has more number of electrons, and for the reductive elimination step you are adding more electron to the metal to make the reduction happen. So obviously it will not happen. Then option is the hinder the elimination process, that means the elimination process will be very much slower. And option B is also the favor the elimination process. No, so elimination process will be hinder, that is slower. If the metal center is electron deficient, then it will always need the electron to, so then it is get the electron from the ligand and go back to the +1 state. So for the reductive elimination process, the metal center should be electron deficient, and for the oxidative addition process, metal center will be electron rich. So here this oxidative addition, it is +1 oxidation state, it is going to the oxidation, that means it is losing its electron. So it will, when it will lose electron, when he has more number of electrons. So for the oxidative addition, this should be electron rich and this should be electron deficient. Then the cycle will continue. Is this clear?
Yes, sir.
Any other question?
No, sir.
Okay. So next question is, the predict the product of the reaction. This is a very simple question, and this reaction, as we are discussing the CH activation. So this question is regarding the CH activation, that is the one of the example of CH activation reaction. What will be the right answer? These types of question will be asked. Did you fill the form for the exam?
Yes, sir.
Okay, then you have to answer or read this thing very carefully, because these types of predict the product of the reaction, these types of question I will also show many question like this will ask in the final exam.
Okay, sir.
So these types of question which I am discussing also asking in the force assignment, you need to look this question very carefully, because this question is going to ask in the final exam also. They predict the
Okay.
product of the reaction.
Option A, sir.
Yes. What is the difference between option A and option C?
Because in weapons, sir. See, these aromatic ring and hydrogens are in interactions. Steric hindrance are there, but in AI, it is not present, I think, sir.
Yes. So in A, you can see that hydrogen which is activated here, this is one, it is A hydrogen, another is B hydrogen. So A hydrogen is close to this other aromatic ring, so that is sort of hindrance, you can say here, and you are right. For that one, that compound C is that the activation of A hydrogen is somehow difficult, then the activation of B hydrogen is, that is the activation of this hydrogen is very easy or compared to the A. So the option A will be the right answer for this question. Same, another I have already told that some question regarding that predict the product of the reaction, and read this question very carefully. This is going to be asked on exam also. Predict the product of the reaction. Okay, here in this section actually two-step reaction. First, the application of light, that is H nu. Another is application of this reagent to the reaction system. What is this? This is CH3, CH3, CH3 and CH3. So addition of these to the H nu. When this complex react with the H nu, it will give iridium, and this CP ring with the methyl substituent, we are calling it CP star. You know, I think it is called CP star. When the cyclopentane ring with the 5-methyl substituent, so CP star and PMe3, and it will give the minus H2O, that is the evolution of hydrogen gas in presence of light. These two hydride will remove as H2 hydrogen gas, and then the it will active the one of the CH bond from this reagent to get the corresponding complex. So here this hydride will be transferred to the metal, and this will act as a, so here it will be H hydride, then CH2, C, CH3, CH3, CH3. This is one of the very important reaction in this step. So here, then what will be the right answer? Option number
Option C. C, sir.
C. Option C will be
Yes,
the
sir.
right answer. Then for the next question, with this iridium, we have our cyclopentadienyl ring, which is methyl substitute, then PPH3 hydride and hydride. What will be the total valence electron for this complex? Also, this is converting to iridium. Calculate the total valence electron. If you can calculate the total valence electron, you are going to get many marks in the examination, which is very important to calculate the total valence electron.
Both are having 18 electrons. 18 electrons, sir.
Both are 18.
Yes, sir.
In which group iridium is there?
Iridium, cobalt, rhodium, iridium.
Hmm.
That means 7 plus 9.
7 plus
7
9.
plus 9. 7 plus 2, 9, sir.
Then
9 plus 1. Hydrogen is 1, 2.
then
Plus 5, sir.
is this correct?
10. 18, sir. Okay, sir. In this also, it can obey 18 electrons.
Yes.
So it is more stable.
Yes. Okay.
Okay, sir.
So 18 electron, or counting the valence electron. Counting the valence electron for different complexes is very much important. Okay.
Okay, sir. Okay, sir.
Next question is the product of the reaction. Do you know the answer?
No, sir, I don't know. Because all the in all the options, the compounds having obey the 18 electrons. All compounds obey the 18 electrons. That's why I didn't identify the answer.
Okay. Sometimes that the previous one also, that compound obeys 18 electrons, but only the help of 18 electron rule it may not be possible to answer all these questions. Okay.
Yes,
Okay.
sir. Yes, sir.
So for that you need to just know the particular reaction, what is happening, and these few reaction which I am discussing here is very important from both your exam point of view as well as the assignment point of view. Okay.
Okay, okay, sir.
So you prepare, whenever you prepare for this exam, just prepare for this some particular reaction which may be asked in the exam. So here you have again that H nu part, and we have that CO, carbon monoxide, attached to the metal. So we know, or we have knowledge, that when hydride or CO is attached, it will remove the hydride as a hydrogen and CO as a carbon monoxide gas, and after that it will have, can act as an active catalyst. We are adding methane, CH4. So what it will do, it will undergo the same CH activation reaction, and then it will form the sigma alkyl complexes. So here first this carbonyl will leave, and then it will undergo the CH activation reaction with the methane, and that will give our desired product, that is CO. And for the CH activation of methane, what will happen? It will clip the one of the hydrogen to give CH3 and
CH3 H. Okay, sir.
okay. Okay. So
Okay, sir.
the role of this molecule is to do this remove of one CO, and to perform this reaction and make this as an active catalyst or active metal sigma alkyl complex to active this hydrogen, to active this CH bond. So what will be the right answer?
Option B, sir.
Option B. Okay. So option B will be the right answer for this. One thing, that here C6F12, that means this moiety, this group you can see here, huh? So
Yes,
here
sir.
the fluorine, that is the carbon fluorine bond, is highly strong bond, and that cannot be break, or that cannot be active under normal condition. You need to force it to active, rather than the CH bond, because the bond energy of CF is more than the carbon hydrogen. So this activation, this is the CF activation for these complexes. Okay. So CF
Okay.
activation is difficult to happen. You can see that one fluorine came here, and it is joined with the iridium is joined with the carbon. So that active as the same which is happening for the CH3, CH, H, H, H. So this one hydrogen goes there, and this CH3 moiety is attached to the iridium. Like the same thing happen also for the C6H6. That one fluorine is goes to the metal center, and that carbon is attached to the iridium center. That will not happen because of the high activation energy. Also, if this is not happen, the fluorine will not come out to the system. So this one is also not possible. as the CH activation is happening, so it will make the hydride complex, not the dialkyl complex. So this is also not possible. Okay, so one thing to note, that the activation of the fluorine or activation of the CF bond under normal condition is difficult. We'll read in the next week, that is in week 5, that activation of CF bond is difficult rather than the activation of CH bond. Okay, the next question is the predict the product of the reaction. This is again another question of CH activation, but you need to find out which CH will activate and which will not. And during CH activation, you have already seen that will form a metal hydride complex. Okay. Okay.
Okay, sir.
So here in all the CH activation reaction, we have seen that we are having a metal hydride complex. Here it is, and the next question, here we are also having a hydride complex. So
Yes.
as I told earlier, that if you understand or get the question that this is a CH activation reaction, so you can easily have eliminate two options, that your option or your answer should have the CH activation and it will be a metal hydride complex. So with that you can easily eliminate this option A and option B. Is this correct?
Yes, sir.
So then your option is remaining C and D.
And
With that option, so if it is forming an hydride, so that means it will extract an hydride or H from this system. Here you can see, if you see here, it is substituted with methyl, and here it is also substituted with methyl. So here and here, this 2 point does not contain any hydrogen. So only possible way to activate the hydrogen is this CH2. The CH2 hydrogen is more easy to activate than the CH3 over here. That's why this CH3, there is 2 hydrogen. One will go to the hydride metal to form the hydride complex, and that this carbon will form the bond to the metal to give the option number D. And this molecule, this is a tertiary butyl group, and this is a very bulky group attached to the metal, which will eventually leave. Okay, so here
okay, sir.
option D will be the correct answer. Then in question number 11, so we have completed question 10. Now the question number 11 is, in case of diamagnetic transition metal complexes, coupling constants of CH protons with agostic interaction in carbon 13 NMR is. So this is the, I have discussed in the first question, that how you determine or detect that agostic interaction in the complexes. Mass
Option B. Option B.
Yes. So here the coupling constant is, it is less or more than normal CH bond. Coupling constant of CH protons with agostic interaction will be less than or more than normal CH proton, which does not contain any agostic interaction. Option B is correct. Let's say we have CH protons which does not contain any agostic interaction, and we have a CH proton which have an agostic interaction. Which coupling constant will be more and which will be less? Okay. So when a metal center is undergo these types of agnostic interaction, that means some of the electron density are building over the metal and hydrogen, and in the same sequence that electron density in the carbon and hydrogen bond decreases. That's why this carbon hydrogen bond become weakens, and for that reason the agnostic the complexes having the agnostic CH protons will show the less coupling constant compared to the CH bond doesn't show the agnostic interaction. So this value is normally less than the normal value. Okay, is this clear? This bond
Yes.
length will be less, and that's why the coupling constant will be less than normal. Okay,
Normally it will be,
more.
sir,
Normally it will
more.
be more, like 110, 120. But for
Okay.
the agnostic interaction, we are considering about this coupling constant, this carbon hydrogen. Okay, because
Okay,
of
sir.
this interaction, hydrogen electron cloud is sharing with the metal as well as with this carbon. For that reason, this bond is getting bond strength decreases, and coupling constant is generally described how strong the two atom is attached to it. Okay, if it is too far, then coupling constant will be less. You can see the 1J coupling, 2J coupling, 3J coupling, 4J coupling, right? You know it.
Yes, sir.
As
Yes.
that J value
Yes.
increases, coupling constant decreases. Okay.
Okay, sir.
For proton, if we considering the coupling of the proton, see 1 minute. If you have the coupling constant of proton like C H C H, so this is the what coupling? If we consider these two, this is, you have read it or not?
Yes, sir.
You know this 3J coupling?
It can be separated by 3 bonds. So that's why
Yeah. Yes.
hydrogen, hydrogen.
It can be separated by 1,
Mm.
2, 3 bond. That's why it is called the 3J coupling.
3 bond.
So when we are considering the proton
Yes.
NMR, we are having 3J coupling if it is separated by another hydrogen like this hydrogen and this hydrogen, then that will be 4 bond. These two if we consider, that will be 4J coupling. As the distance between the bond increases, the coupling constant decreases. That means the interaction decreases. So for that, this one, because of the hydrogen interacting with the metal, this bond getting decreases constant. That's why the coupling constant also decreases. Okay.
Okay, sir.
Another is next question. A typical CH bond length in agnostic interaction is. We have two CH bond. Let's say this is CH1 and we have CH2. What is the difference? This one have agnostic interaction, this one does not. Okay. So which bond length will be more and which will be less? I am discussing this agnostic interaction since the starting of this today's session.
If it having agnostic interactions, the bond length is increases.
Yes.
If does not having agostic interactions, then the bond length is short when
Bond length
compared to the
agostic interaction. Yes, that is correct.
does not having. Yes, sir.
Yes, it is correct. So here our general or normal CH bond length is 109 pm. Okay.
Okay, sir.
So for the
109.
agostic interaction, it will be just more than 109. So here correct answer is option number D. So for the
Okay,
agostic
sir.
interaction, so normal one is does not have 109. So it will be slightly more than that. So, so the proton having the agostic interaction, bond length will be slightly more than normal bond length, which is 113 to 119 ppm. It should be pm, not ppm.
113 to 119.
It should be
It should be 113 to 119
yes.
ppm. Okay,
It
sir.
should
Okay,
be
sir.
pm, picometer,
Okay, sir. Okay, sir.
not ppm. Okay.
Okay, picometers. Okay, okay.
ppm is different. ppm you know, I think.
Parts per million. Yes,
Ah,
yes, sir. Yes, sir.
yeah. ppm is different. Okay. It should be pm.
Yes.
Okay. The next question is a general question. The application of CH activation to do the alkene functionalization, disintegration of alkenes to CO2 and H2O, nitrogen fixation, or the redox reaction. Why we need the CH activation reaction? After doing that activated CH,
Alkane functionalization. Option A, sir.
yes. So option A will be the right answer. So that with the help of catalyst, we are activating CH bond, and then we are adding any functional group to make CFG. That is, we are doing the functionalization in the carbon center to give, like CH4 we have, we are converting one of the hydrogen to CH3OH. We are doing the functionalization over H. So we are doing the alkene functionalization. Next question is the cleavage of CH bond during CH activation by a transition metal involve.
Agostic interactions.
Yeah, that is correct. This is one
Okay,
of
sir.
the answer.
Yes, sir.
Each had more than one answer. If you answer one, you will not get the full marks, and it will also considered a wrong answer.
Oxidative addition, sir. In beta elimination, beta hydrogen elimination.
What?
Oxidative addition, sir.
Yes. So without oxidative, so agostic interaction is giving rise to oxidative addition. Okay.
Okay, sir.
Then this is the two consequence of or CH activation the transition metal involves. First is the acoustic interaction, then is the oxidative addition. Is this clear?
Yes, sir. Yes, sir.
Okay. Next question is the reaction that doesn't occur for D0 metal complexes.
The reaction does not occur.
Does not is on bold. Will
Yes,
not
sir.
occur. I have already discussed the oxidative addition and reductive elimination by making that circle when we are discussing
Oxidative reaction means
this one, this one.
D0.
Okay, so
Yes, sir.
you should recall this and answer this question.
Reductive elimination, sir.
Okay. So another thing that, as I told before, that you can do that option elimination thing. So as we are talking about the D0 metal, D0 means metal center contains some electron. That means we are talking about the electrons. So you
Yes.
can see that option number C and D, this does not bother the electron count. Only the oxidation reduction there is a change of electron. Okay. So in this regard you can directly eliminate the option C and D. Okay.
Okay, sir.
So it has the oxidation means
Addition of that means it will increase the oxidation state and increase the coordination number also.
hmm. So it will oxidation state means that it will increase the oxidation state. Like if it is 1, it will be 3. If, that means it is loses 2 electron, right?
Yes, sir. Yes, yes,
And
sir.
and for the reduction is, if it is 3, it
The
is
oxidation state and the
will be
coordination number decreased by
de-
2 units. Yes, sir.
okay. That means it is gaining 2 electron. That is positive 2 electron. So it is
Yes,
saying
sir. Yes,
that
sir.
the metal center having D0 electron.
Mm.
D0 electron, that means the metal center in its highest oxidation state, and it does not contain any valence electron. Okay.
Yes, sir.
So if the metal does not contain any electron, so is it possible to take out two more electron from it?
No, no.
It is not possible. That means that oxidation process is not possible,
Mm.
but
Yes, sir.
it can have the electron. We can give two
Electron.
electron to the metal. That
Yes,
means
sir.
this process is not possible, this process is possible. So here the question is that the reaction that does not occur. That means
Yes.
this oxidation reaction does not possible for D0 system. So option A will be the right answer.
Yes, sir.
Is this clear?
Yes, sir. Yes, sir. Yes.
Okay. The next question. Next question. This is also, you can solve it like the same way I solved the previous one. That is the approach of the question.
Aromatization, sir.
Yes. Okay. So the reaction may be, here it is saying that the reaction may not be called A. That means you are not, which may not be called. So the negative answer you need to find out. So this is the oxidation reaction. Yes, here it is increasing from 1 to 3. This is not cycloaddition. It should be cyclo. Is it oxidative addition? Yes. Is it orthometallation? Yes. Why? Because this bond which is activated or attached to the metal is ortho to this phosphorus, right? Then it is also the orthometallation. Is this oxidative addition? Yes. Then it is the cyclometallation? Yes. Because it is here it is a metal cycle is from iridium, carbon, carbon, phosphorus. That means the metal cycle is forming. It is a also cyclometallation reaction. But here we need may not. So our right answer will be option number D will be the right answer. This is not an aromatization reaction because here everything is aromatic. We are not breaking or making aromatic ring. So right answer is option number D. Okay. So then predict the product of the reaction. Here there is no option. Just you have to tell me the product. What will happen? And this one also and this one also. And I pick up these two reaction for there is a reason. Now what will happen? This is what is this? This is a this is a
Hence,
this is a
octane.
alkene, and we are reading about CH activation. Okay.
Yes,
So
sir.
here you can see multiple CH is there. This is the terminal one. Here also have H. So we have terminal CH, as well as if we count, this is 1, 2, 3, again this. So multiple CH is there. So using this catalyst, that is the rhodium C5H5 eta 5, then eta 4 C6H6 Me6, this catalyst is the catalyst. This question is very important in exam point of view because this catalyst act to activate this terminal hydrogen in presence of this boronic acid ester. It from this long chain with boron, oxygen, this ester it will form. What is the use of this ester? This molecule is, this long chain is very important. And why it is important? Because this molecule is a starting material or substrate for the Suzuki coupling reaction. Have you heard of that?
Yes, sir.
So this boronic acid or boronic ester molecule is required for the Suzuki coupling reaction, and any alkene molecule like this can make this boronic ester using this rhodium catalyst to perform the Suzuki coupling reaction. Otherwise making of this boron compound or boron substrate is very difficult to get the CC coupled product in Suzuki coupling reaction. That's why this reaction is very important. Okay,
Okay, sir.
this is very important in exam point of view also.
Okay, sir.
Then
Here CH bond is cleaving
CH bond is cleaving and it is
and boron ether is attached.
boron it has attached. Yes,
Yes. Okay, sir.
you can have this in the last lecture, I think.
Okay, okay, sir. Okay, sir.
Note it properly when you are making notes. This reaction is very important. My duty is to point out the important reaction so that you can do the answer in the final exam.
Okay, sir.
So
Okay,
this
sir.
reaction is another important reaction.
Okay, sir.
Next one is this one. This one is also another important reaction. That's why I did not discuss the option. This one is another, and still now we have detect the CH activation, agostic interaction, right? So for the agostic interaction is consequence of CH activation, but we have said that neutron diffraction studies that decrease of coupling constant for the CH bond in N13C carbon NMR studies is one of the experimental proof that we are having agostic interaction in the metal. But for this reaction we are having a product in which we have the crystal structure for this. That means the product is structurally characterized, for which we can say that agostic interaction is must happen in the system to get these types of product. Other one is not structurally characterized, is just an intermediate thing, or we cannot characterize structurally because maybe the sensitivity and all. Okay, so this molybdenum and this is an activation of SiH bond which is similar to the CH bond. Okay, here the correct answer is molybdenum, and we have that phosphorus ligand, phosphorus, and phosphorus is substituted with 2-ethyl, and again phosphorus, and phosphorus is substituted with 2-ethyl, and we have that activation of hydride, making the hydride complex with the SiH3, like CH3 we are having. So this is SiH3 and CO is already present in the system. Okay, so CO is already present in the system. We have our this HPET2 ligand, CH2PET2 ligand, phosphine, and this molecule is characterized by structurally, that means with X-ray crystallography, which proves that hydride complex is forming during the cleaving of this CH bond to give the, so that's why this reaction is very important reaction. Okay, is this clear?
Sir, yes, sir.
Why this reaction is important, that is also clear. So we have the X-ray crystal structure proof to have that agostic interaction as well as the CH activation in the medium, and we can also say that the CH activation or functionalization is going through this hydride complex. Okay, with this I think I have completed all the question. Do you have any other doubt?
No, sir. No, sir.
You are getting the slides in the drive?
Sir,
Hmm?
Sir, I have a doubt.
Yeah, yeah.
Why transition metal sigma hydrido complexes are not stable? What is the reason behind it?
Yeah, sigma hydride complexes are not stable, obviously not stable, but that's why we are not deducting the structure for the other complexes. But some complexes may be here is gone 1 minute, which I have drawn it just now. That
Yes,
complexes may
sir.
be stable because of that steric region. Okay,
Okay, sir.
1 minute. Let me open that one again. Computer gets hang. We have seen the last complexes which I draw, that phosphorus is bound to the metal with that
Yes, yes, sir. Molybdenum.
um, molybdenum is the metal. Molybdenum metal is bound to the several bulky group, that if each ligand, that CH2 P for P ET4 and P2 ET4, and that ligand is so bulky, so big. So maybe I don't know the actual reason. It may be one reason that because of that bulkiness, that hydride one and Si3H and in going inside the cavity and make a single molecule, and that's why it is easy to get the structurally characterized molecule. Okay, that may be the one reason. I do not know the actual reason why a single molecule is crystallizing, why is not. Okay, so there is no particular
Okay.
reason like that. So this is just for an example, or we are having a proof that there it is going through that hydride step. But metal hydride.
Actually, this question is answered in the assignment, sir.
Hmm.
Uh,
What is the
so
answer?
that's why
Is it answered in book?
I have doubt on that question, so that I asked you, sir.
Actually, it is written that what is written here? What is for the stability?
Actually, in the options they have given that they decompose to alkenes and they undergo alkane elimination
Hmm.
and they undergo alkyne elimination and they undergo beta elimination, sir.
Hmm.
These are the four options they have given.
Hmm. But maybe at the some low temperature, or they have the stable. That's why. Okay. So many complexes are may not stable in the normal temperature, but if you go
They are,
lower temperature,
they
or
are stable at elevated temperatures.
yeah, at lower temperature or in inert condition, it may stabilize. Okay, just like that. Some complexes are stable, which are not. It is very difficult to stay like this type of complexes. Also, I have seen in the last series that with generally the electron deficient one undergo the that is the electronically unsaturated complex undergo the reductive elimination or oxidative addition or beta hydride elimination, but 8 electron complex also undergo the beta hydride elimination. That is, there are some few examples, so that's why it is difficult to say. Do you have any other doubt
Um,
for
and
particularly?
one more doubt, sir. This is regarding the assignment only. They asked the question. The actual oxidant of platinum catalyzed functionalization of methane to methanol and methyl chloride.
Hmm.
Mm, I know. I think 90% of the answer is platinum chloro 6 2 minus complex.
Okay, 1 minute. Let me open that. That is for the assignment for this course, right?
Yes, sir.
One
This is
minute.
regarding that.
1 minute. You wait little bit. I will open it. Then I will show.
Okay, sir.
Wait, I am opening it.
Okay, sir.
Just my computer is little bit slow. This year assignment you are talking about, current assignment.
Yes, week 4 assignment, sir.
Current assignment. 1 minute. I have the list. I need to go to that website to get it. 1 minute. Week 4, na?
Yes, sir, week 4.
Which number?
Question number 4.
4. The actual
4, sir.
oxidant for the platinum catalyzed functionalization of methane to methanol or methyl chloride is. Okay. So I will not tell the right answer, but I can explain the question. The question is saying that the actual oxidant, right?
Yes, sir.
Oxidant means what? Oxidant means it will do the oxidation, right?
Yes, sir.
And it will get reduced, right? So
Yes, sir.
something will get reduced when it is in
Ac-
high oxidation state.
Actually, yes, sir. In platinum 6 2 minus complex, the oxidation state of platinum is +4.
Hmm.
By undergoing reaction, it will convert. It will reduce. I am thinking like that, sir.
Yeah, that is the thing. That is the thing.
As I am thinking it is 90% correct, sir. Just for confirmation and clearing my doubt, I asked this question, sir.
Yeah, you are thinking in right way. That whenever oxidant means it will do the oxidation and itself it will get reduced. For redox, for itself get reduced, always it should be in high oxidation state.
My oxidation state. Yes, sir.
That will be you got your answer.
Yes, sir.
Okay. Any other doubt? But I cannot tell which will be the right answer.
Yes, sir. Yes, sir.
Because this will calculate your marks, right?
Yes.
Okay. Any other
Sir,
doubt?
can you explain the 10th question, sir?
Question 10. Is that the major product of the following reaction? Iridium called whole 2 plus. This is a I have already told that you need to particularly prepare some reactions for the exam. Okay, so this is like a particular reaction. You need to just search in the book or whatever. It's a particular reaction. There is nothing to explain here.
Okay, sir.
But I can give you hint. What hint? Hydrogen what will do? And what is the oxidation state of iridium? Do you know the structure of quad ligand?
Yes, sir. Cyclooctadiene.
it is ionic or neutral?
I think it will donate -1.
Cyclooctadiene. Then draw the structure of cyclooctadiene. So this will be iridium, okay, and cyclooctadiene is something like this.
Subships.
Yes, this will be another. And this will be, and here it is positive charge +1.
1.
What is supposed to happen? Plus hydrogen. We are discussing in today's lecture repeatedly. Focus on the oxidation state.
It will undergo oxidation.
It will undergo oxidative addition, simply. Is this correct?
Yes, sir.
And +1 will convert to
+3.
+3. That's. But what will be the correct answer? I cannot discuss. In oxidative addition, here the two option. Here also you can perform the elimination trick. And oxidative addition happens in a particular fashion, that is cis fashion or trans fashion. I will not say which fashion, but you find out and find out the right answer. Okay?
Okay, sir.
Any other doubt?
No, sir. Thank you.
Okay. Your doubt is clear for this question?
Yes, sir.
Yeah. Okay. Okay then. Thank you. I will happy to have the doubt in all the session. So, or you can ask your doubt directly to the discussion forum also. But that I have discussed. I have not discussed the answer for any of this. I cannot discuss the answer for any of this current assignment. But if you had doubt related to that question, I can clear it. But I will not discuss the answer for this question, because you know this will calculate your marks for the final exam, right? Is there any marks contributed to the final? I think, na? In 12 week 10 assignments, so it will be 120 questions will be there. So this will contribute some marks. I don't know actually. I am not sure how it will contribute to the final exam marks or not. But
Yes, sir. It will contribute, sir.
Okay, then I cannot discuss openly the answer of that question. You just read the book, find out in the book, and give the answer. Okay?
Okay, sir.
Any other doubt?
No, sir.
You are enjoying the course?
Yes, sir.
You are from undergraduate or master degree MSc level?
I am not a student, sir. Actually, I am assistant professor from my college.
No, then don't tell me sir. Okay, then don't tell me sir. I am just a PhD student.
No problem, sir.
Okay. Then why you registered for the exam?
Actually, in our college, we want to do at least one course per semester. Regarding that, we are registering for the NPTEL courses, sir. Actually, in last semester, I completed transition metals course. It's a 12-week course.
Catalysis and biology.
No, sir. It is from advanced transition metals.
Okay, advanced transition metal.
Yes,
Metal. I also to take these types of live session for that course also. But you did not join anything.
It was somewhat easy for me, sir, regarding that course.
From the same professor or different?
Different professor. It is from Balakrishna sir.
Yes, yes.
Professor Balakrishna.
Balakrishna sir also from IIT Bombay.
Yes, this IIT Bombay.
Yes, yes. Okay. Okay. Then if you have any doubt regarding the exam pattern or question, you can just post your doubt in the discussion forum. Then we will try, the professor will answer, obviously. We are just TAs for the course. We are having to clear the doubt mainly for the student who are giving the exam. Okay, so if you have any doubt in your discussion forum, not like my content, just content from the original video, you put the lecture number, video time, and put your doubt in the forum, and after discussing with the professor we will put the answer in that. This is working in that way. So if you have any, you can put it in the discussion forum. Okay.
Okay.
Okay. Any other people have any question? If not, then I will close this session.
Nothing, sir. Nothing to add.
Okay. Thank you. Okay. Thank you again for joining this session. I hope this will be helpful for the preparation regarding the exams of this course. And if you have any doubt regarding the course, just put your doubt in the forum, and hope to see you in the next Tuesday on the same time, 6 to 8 p.m. And as per the last classes in requirement, I have added more question so that you will get or to know what point is more important in regarding the exam point of view. Okay, thank you for attending this session.